Okay, so today a student stopped by for office hours and they had a WebAssign question. I looked at it, I solved the problem. I realized I probably confused the student after I solved it. But what I want to claim over here is that, maybe a visual understanding of the problem before I go, like blindly through algebra. And it's really nice to be able to have some sense about these problems over here. And I didn't do this in the office hours, and I apologize. But what I would do is I would graph each side. And as I do this over here, I want to graph the cosine function, and the cosine function, it looks sort of like this, and I'm going to do the best job I possibly can, right? And that's between 0 and 360. The point wise, there's five really characteristic points in this, and then the question comes, what does a sine function look like? Well, if you were to do the sine function, it's being shifted down one, right? So I gotta go down here. I hope you realize I'm shifting that sine function down one. So what it'll look like, it will look sort of like this over here. I'm shifting it down one, all right? And what does it look like if I did that? Looks like this over here, then this over here. I think I did it right there. Let me see if I can do that. So then the story becomes this, and that's a sine function shifted down one. Do you know the points of intersection over here? And I think they're somewhat simple. I'm going to say if I looked at it, this would be pi over 2, and this would be pi. All right, now if I'm going to write this down the way we've been doing in class, by the way, I would say theta is equal to pi over 2 plus 2 pi k. Theta is equal to pi plus 2 pi k. All right, and I'd say I'm done with the problem. All right, now what I did, and I'm not saying it was wrong, I'm just saying that I probably confused someone by doing it. And what I did was I just simply didn't think, I just did straightforward algebra. So sine theta equals cosine theta plus 1. At least I think I did it. Maybe I didn't do that. Oh, you know what? I didn't do that. Let me erase it. I remember what I did now. I think I just squared both sides. Let me do that. And so it says, why would you do that? I'm always going back to the most simplest thing that we've got, which is getting into one function. And I'm going to square both sides. By the way, we'll get the same answer. Don't worry about that. So what do you get? Sine squared theta minus 2 sine theta plus 1 equals cosine squared theta. Now, I realize some says you made it worse. Maybe. Sine squared theta minus 2 sine theta plus 1. And cosine squared theta is actually 1 minus sine squared theta. Well, what do you notice about this over here? It looks pretty easy to do. And what I mean by that, I'm going to add sine squared to both sides. I get 2 sine squared minus 2 sine theta. And if I subtract 1 from both sides, I just get 0. And I'm going to factor it. And if you factor this guy, what do you get? You would get, let's write this down, 2 sine theta. By the way, the problem with algebra is you're not thinking about the original problem anymore, which is a misfortune, by the way. And you get sine theta minus 1 equals 0. And if I were just to write the answers down for this over here, what I would do, I'd say sine theta is equal to 0, or sine theta is equal to 1. Now, by the way, the sine function looks like this over here. And I'm going to say the 1's really easy to do. What's going to be theta would be equal to pi over 2 plus 2 pi k. All right, that's really easy to do. Now, the sine of 0, by the way, a little more complicated, but it's going to be theta is going to be equal a multiple of pi. That's all it is. I'm going to put pi k down. Now, granted, I hate to say this, a lot of times I'd stop thinking at this point and say, oh, I'm done with the problem. And this is where I confuse the students. I'm not done with the problem. I've got to go back and I got to look at the original problem. And this is the original problem over here. And by the way, my answers are this over here. All right? So then the question becomes is, Did I get it? And I got to be honest with you, I got this, right? But I'm saying that this can't be right, all right? But the pi over 2 is fine. I did get it, just by visualization. I want to talk about why this one is actually wrong. And it comes from not thinking. And I want to go back to the original problem. And the original problem, I want to remind myself, sine theta minus 1 equals cosine of theta. And if you were just, think about this, this would lead to a variety of answers like 0, pi, 2 pi, 3 pi, 4 pi, so forth and so on, right? Well, let's just check it out and see what happens. All right, let's see what you get over here. And, if I try the 0, that's k is 0, right? What do you get? Again, I'm going to try the 0. You would get minus 1 equals 1. This is nonsense, all right? Now let's try pi. What's sine of pi? Well, sine of pi is 0, right? And sine of pi is 0. I'm checking this one out. And you get 0 minus 1 is minus 1. What's a cosine of pi? It's minus 1. So that works, right? That works. Now, does this one work? And the answer is no. So what I'm really getting, I'm getting pi plus 2 pi k. It keeps repeating itself. All right, let's go back over here. And that's the answer, correct answer over here. And again, I know I confused the students when I did it. And I hate to say this, I'm guilty of not thinking. I'm guilty of not thinking. But this is the correct answer to the problem. All right? Thank you for paying attention, though.